Hello everyone. I am Amit Kumar, the assistant professor in AKGEC in the IT department. Today I am going to give a brief introduction of Boolean algebra. This comes under the discrete structure. It is for the second year students. And what is the use of Boolean algebra in our life? What is the use of Boolean algebra in the computer science? I am going to tell about this and what is the how we are going to use the Boolean algebra in our day-to-day examples. What is Boolean? Boolean is for two numbers 0 and 1. Okay, computer understand only two number 0 and 1. Okay, so the 0 and 1, if computer understands 0 and 1, we the human beings, we do not know all the values of 0 and 1 how to put, but computer understand the low level language and we the human beings are understanding the high level language. So for the computer level language, we are doing the algebra, we are doing the operations with that and we find this conclusion and how we are going for that one. So Boolean is developed by English mathematician George Boole between 1815 to 1864. That the mathematician, the scientist who have invented the Boolean, his name is Boole. That's why the name is Boolean. He has founded it. He has developed it. Next, it is described as an algebra of logic or an algebra of two values, that is true or false. I have told you, computer understanding 0 and 1. What is 0? 0 means false, 1 means true. If the values are 0 and 1, okay, it describes an algebra of logic or an algebra of two values which is true or false. The term logic means a statement having binary decisions, means they have the binary decisions only, they are on true basis or they are in false basis. They don't lie in between of true and false. Now, what are the application of Boolean algebra? It is used to perform the logical operation in digital computer, because we have to operate it, we have to give some operations on that. In a digital computer, true is represented as 1 and false is represented in 0. Okay, logical operations are performed by logical operators. And what are the logical operators? And, or, not. And is also called as conjunction, or is also called as disjunction, and not is also called as complement or negotiation of that logical operations. So what is the AND operation? It performs logical multiplication and denoted by the dot, AND operation. Okay, so these are the two things which I have took, x and y. 0 0, if the values is false, then the multiplication is also false. If values is one value is false and another value is true, then it also output will be generated as a false. One value is a true and another value is a false, then it is also false. If the value is true and the second value is also true, then it is true. In the AND operation, 1 1, then it creates 1. Now OR operation. OR operation performs the logical addition and denoted by plus sign. Okay, x and y is denoted by x plus 1, means false plus false, then false, false plus true, true, true plus false, true, true plus true, then it is true. This is the OR operation. Okay, this is the truth table of the OR operation. NOT operation, it performs logical negotiation and denoted by bar sign. It operates on the single variable, like x to x bar. This is x bar, means complement of x, means what is the complement of 0? 1, and what is the complement of 1? It is 0. Okay, truth table, as I have told you before that what is truth table, but now truth table is a table that contains all possible values of logical variables statement in a Boolean expression. Number of composition is equals to 2 to the power n. means if you are taking the, why I am taking the values 0 1 0 0 0, because the values of what is the possible combination 2 to the power, if we have the two values 2 to the power 2, that is 4. If you have the three values 2 to the power 3, then 8, means three values means x, y, z. 2 to the power 2 means x and y. Okay, this is the important formula, number of possible combinations 2 to the power n. Due to this, we have created the truth table. Okay, the truth table for x dot y plus z are as follows. As you have seen the values, because this is the 8 elements x, y, z, as I have took, then in x, y, z means 3 elements 2 to the power 3, then 8. You can show 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7. These are the values. So we have took 0 1 0 1 0 1 0 1 0 0 1 1 0 0 1 1 0 0 0 0 1 1 1 1. This is the table. Then we have to x dot y means false 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 true false false true false true false false true false false true 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 true. Then we have to take x, y, we have founded, and plus z. False false false, true false true, false false false, true false true, true true, false false false, true false true, false true true, true true true. This is the truth table for x, y plus z. Next, logical gates. A gate is a digital circuit which operates on one or more signals and produce single output. Gates are digital circuits because the inputs of the inputs and output signals are denoted by 1 and 0. There are 3 gates, and or not. As we have took, there are 3 basic gates, and or not. What is AND gate? The AND gate is an electronic circuit that gives a high output, only if the inputs are high. Only the inputs are high. 1 1. This is the high outputs, and this is the circuit diagram of AND. AND gate take 2 or more input signal and produce only one output signal. We are taking the 2 input signal and 1 output signal. This is the AND gate. As we have took this one, the AND gate 0 0 0 0 1 0 1 0 0 1 1 1. Okay. OR gate. The OR gate is an electronic circuit that give a high output if one or more if more or its inputs are high. OR gate also takes 2 or more input signals and produce only one input signal. This is the circuit diagram of OR. Okay, this is the sign of OR. Okay, and this is the truth table of OR. 0 0, these are both are low, so 0 0 1, one of its element is high, so the value is high, high 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 and high, then it is high. This is how it is created for OR gate. NOT gate. The NOT gate is an electronic device that give a high output if it is if its input is low. NOT gate take only one input signal and produce only one output signal. It take only one input signal and one output signal. Okay? This is called this is also called as a inverter. If the input is low, then the output is high. If the input is high, then the output is low. This is the inverter. Okay. Next is NAND gate, known as the universal gate because any digital circuit can be implemented with NAND gate alone. Okay, it is the combination of AND and NOT. This is the sign of AND and this is the sign of NOT. So X is NOT of X and Y, means X and Y. ठीक है, ये जो वैल्यू है X and Y 0 0 1 NOT of, if we found X dot Y 0 0 0 0 1 0 1 0 0 1 1 1. So we have to find the complement of that one. So that is z. Z is equals to x dot y. So zeros complement 1, 1's negotiation, zeros negotiation 1, zeros negotiation 1, negotiation 0. This is the NAND gate. Just like NAND gate, okay, this is NOR gate, and this is the truth table for NOR gate. Okay, x and y, as we have took input x dot y, x plus y. Okay, 0 0 0 0 1 1 1 1. So this is the output, and NOR gate. This is the NOR gate, means x plus y not sign. Zeros 1 0 0 0. This is the output. You can match it. You can match it. This is the NOR gate. Up to here, what we have studied? What is Boolean? Okay, what is truth table? Who invented the Boolean? In which year he has invented? Why the Boolean name has came from? And now we have learned about the basic operations of Boolean. From up to here, we have learned about AND or NOT gate, NAND gate, NOR gate. These are the topics which cover the Boolean algebra. Another one is exclusive OR gate. This is the truth table for exclusive OR gate. 0 0 0 0 1 1 1 0 1 1 1 0. Okay, this is the sign of exclusive OR gate, and we can say that XOR. Okay, वैसे ही XNOR. This is the truth table for XNOR, XY and Z. 0 0 1 0 1 0 1 0 0 1 1 1. This is the sign of XNOR. Basic theorem of Boolean algebra. There are basic theorems for Boolean algebra. Properties of 0. 0 plus A, 0 dot A, 0. Properties of 1. 1 plus A, 1. 1 plus 1 dot A is A. This is the properties. Next property, commutative property. A plus B is equals to B plus A. A dot B is equals to B dot A. Associative property. A plus B plus C is equals to A plus B plus C. A plus B plus C is equals to A plus B plus C. Now A dot B dot C is equals to A dot B dot C. A dot B dot C is equals to A dot B dot C. These are the associative property of the Boolean algebra or law. Distributive law. A into B plus C is equals to AB plus AC. A plus BC is equals to A plus B dot A plus C. A plus A dash B means A plus B, because A plus A dash is equals to 1. If we can broke it, what? A plus A dash B is equals to A plus A dash, A plus A dash, and A plus B. A plus A dash 1, as we have learned from the property. Then A plus B from the identity law, A plus B. This is the output. Next, idempotency law. This is known as identity law. A plus A is equals to A dot A is equals to A. Absorption or redundance law. A plus AB is equals to A dot A plus B is equals to A. What is complementary law? A plus X dash is equals to 1, X dot X dash is equals to 0. Okay, this is theorem complementary law. Next, involution law. X dash dash equals to X means X dash dash equals to X. This is most important law. Most important. De Morgan's law theorem. X plus Y dash is equals to X dash dot Y dash, and X dot Y dash is equals to X dash plus Y dash. You have to create the truth table also, and you can solve it from by the basic theorem of Boolean algebra to prove the De Morgan's theorem. For the theorem, this one, a dot b bar is equals to a bar dot a plus b bar. This is the De Morgan's theorem as we have took, and how to prove from the truth table as we are taking a and b. We have took the value 0 1 0 1 0 0 1 1. We have took a dot b b bar. First we have to find a bar, then b bar. Okay. A bar 1 1 0 0 1 0 1 0. A bar plus b bar 1 1 1 0. A dot a b 1 1 1 0. You can match it. These two are equal. Means a dot b bar is equals to a bar plus b bar. This is the De Morgan's theorem. Next theorem is a plus b bar is equals to a bar dot b bar. For this we are using if we can use that one from the logic gates, from the logic circuits, you can make through this one, but through the truth table I am solving this one. A plus b bar is equals to a bar dot b bar. A plus b bar, a plus b, here 0 and the bar is 1 0 0 0 0 1 0 1 0 0 1 1. The value of a and b we have put it. A bar 1 1 0 0, b bar 1 0 1 0. Then we have to find a bar dot b bar. We have to find a bar dot b bar. High, both are high, then it is high. If anyone is low, then low. You can match this one. For this, I am calculating a plus b here. A plus b. A plus b 0 0 0 0 1 1 1 1 0 1 0 1 1 1 1. And for this, a plus b bar 1 0 0 0 1 0 0 0. You can match it. These both values are equal in the Boolean. So the truth table of the De Morgan's law theorem is equal. So for that, from here we have learned about what we have going to be learned. These are the explanation which we are having till now. What we have learned, what is the truth table, what are the operators, what is the use of Boolean, who invented the Boolean, how many types of operations, how is truth table is going to be created, how is the logic gate is going to be created, how the digital circuit is going to be created using the Booleans. So these are the theorems which you have. I have took only one theorem, De Morgan's theorem. You can solve this all. These are the basics. You can solve it. You can match it. These are the theorems which you can solve by yourself, and you can match the values of LHS and RHS. It would be the equal values. So these are the laws. From that I have proved one, that is De Morgan theorem for first this one, and for this second one. Okay, this is the, from this we have took the circuit also, we have took the operators also, and by through the truth table also. So thank you so much for today's class. Next class we will learn about what is the theory of logic and what is the theory of inference for that one. Thank you so much.